Our second lab is going to be experimenting on real handwriting data. So we've so far looked at MNest, and then we created a synthetic data set. Now we're going to look at an actual data set of handwriting. And I'm also going to show you how we can do hyperparameter sweeps. So we're going to look at a data set called the IAM handwriting data set. With this, we want to be able to run multiple experiments. And hopefully, if we keep our laptop open, run overnight, and come back tomorrow, the victor with the most high-performing model on the data set, and try some ideas on how we can improve it. So the IAM database, here's a little information about it. It's taken from all of these handwritten letters when people did that. Who here writes letters? Maybe I should. It's kind of like a lost. Yeah, my handwriting's terrible. If I had good handwriting, I would do it. It's so romantic. So we're going to be taking this data set, and actually, we've already pre-extracted the lines of text, and that's what we're going to be training on. So if you go into Lab 4, we can look at the data set. Notebooks is cool. Cool. So feel free to run this notebook. We'll just look at it. So the IAM lines data set has a very similar mapping as MNest, right? We've got essentially the same vocabulary. We've got this nice mapping on the dataset object that lets us convert the indices into their actual characters. And then we can convert all of these labels into what the actual string is. So for actual spaces, we have spaces. For emptiness, it's underscores. And then here we can actually take a look at what the actual data set looks like. Cool. So we've got another README in this directory, which we can start from. So inside a task, we have a train LSTM line predictor on IAM, which will do exactly what it sounds like it'll do. So this model is using the CTC loss as described in the earlier lab. It's kind of slow. But thank goodness we've got multiple GPUs. So if we go ahead and look at the run in weights and biases, we can see that our graph looks wild and actually doesn't make a ton of sense, but looks pretty. We can see that because we're not only sequential now, that we've got the CTC loss inputs that we need to actually calculate the loss. The stuff going on here is like, it's wild. It's probably like a bug, but yeah, Tom wrote it. He's owning it. I think it's kind of pretty. I don't know. I'd show this to my boss and be like, look what I made. I mean, the important thing is that the network actually has two outputs, right? It has the CTC loss, and then it actually has the decoded prediction. And to calculate some of those, it needs these different values. Like the decoder prediction needs the input length, the actual length of whatever our input is, because it can handle variable length input. And the loss calculation needs input from various places. Cool. So here you can see we've got some different metrics here, CTC loss. A lot of these are actually overlapping, because in Keras it has the default loss function, but then we created these like other losses, so they're a bit redundant, but that's just the default Keras behavior. If we go back to this table, we can say, OK, let's actually only look at IAM line dataset runs. Hopefully. Bingo. And then we can say, all right, let's sort by ascending loss. I don't know what I was training here. I must have done a really good job. Where's S. Suresha? Right on, man. Cool. So this will actually be kind of a running leaderboard as long as you guys keep the entity set to FSVL. We can have you guys train overnight or keep the browsers open and come back tomorrow and actually see who can get some performance out of this network. So I want to quickly go over hyperparameter sweeps. So I'm going to go ahead and kill this run and talk about how we could do a hyperparameter sweep using the weights and biases backend. So inside of training, two new files. One is run sweep. So the way weights and biases sweeps work is you configure a sweep, and we give you a unique ID, and then you run an agent kind of anywhere in your infrastructure. And you can run multiple agents. So the way you do this, you just say WB agent and then this sweep ID. And all that agent's doing is phoning home to weights and biases, whether that's hosted on your network or the cloud, and saying, what set of parameters should I try next? We tell it, and then it passes those arguments in as command line arguments to your script. And then we go off and run the job. So for these experiments, we're actually passing in JSON. So I had to write this wrapper that's going to convert command line arguments into JSON, essentially. So then we can call run experiment with the actual JSON for the experiment config. And then I've got two sweeps. So one sweep is for IAM, which is the model we're just running on the new data set. It's too dang slow for me to have a sick demo. So I also made MNest, which is just the character model. And you can see we're doing a simple grid search here. We've said what metric we want to minimize, but the sweep engine's not actually going to use that because we're not doing any kind of fancy sweep logic. We're literally just going over this grid of parameters. So here I'm saying I want to try a layer size 128, 256, dropouts of 0.2, 0.4, et cetera. So these are all discrete ranges. There's a link to the sweeps docs in the slides. But essentially, our sweeps support a number of different search strategies. So first is grid, which is just saying, give me some set of discrete values, and I'll try them all, and I'll tell you which one works the best. We also support random search, which there, if you don't want to specify discrete values and instead you want to specify ranges, you can tell us what those ranges look like, and we'll randomly sample from them. And then we also have a fancy Bayesian search strategy that uses Gaussian processes to kind of try to be intelligent about how it explores this search space. In the world of hyperparameter search, I think the more exciting, the kind of more exciting strategy, other than being really smart about picking which parameters to try, is early stopping. So we implemented the Hyperband paper, which was mentioned earlier, that is an early stopping strategy, where essentially we'll try a few runs, see which one's performing the best, and then after some interval, now we're going to start stopping runs if they don't look like they're going to exceed our current best performing run. So you don't have to search the entire space. It could potentially save you compute. Cool. So before we go on break, let's go ahead and start our own sweep. So the way we do that is from lab 4. We run W&B sweep training, and let's do sweep mnest. So this is talking to the weights and biases API and saying, hey, I want to make a sweep with this configuration. And then we copy this sweep ID. And maybe for posterity, I just export sweep ID equals that. Sorry, without the $sign. And then now I can run an agent. You can tell it's an agent because of that emoji of an actual agent. It's ridiculous. OK. So here, the agent phoned home and said, OK, I'm going to try these 5 hyperparameters first. So these are the ones it's trying. And it's running away. So now if we want to run these experiments in parallel, we can start another agent. But first, I think I actually need to copy my sweep ID if I haven't already, because it won't be in the environment of the other shell. Cool. So now the one thing we have to change before we'll be able to actually run this in parallel is by default, my run sweep is not passing in GPU equals -1. So here we can just add -s GPU, -1. So now this means it's going to pick up any available GPU as opposed to just using the GPU 0.
After the sweep ID, what was the command again?
What was that?
After the export sweep ID, what was the command?
W&B agent. So here I'll also export sweep ID. Now I could say W&B agent, and then I need to pass in the sweep ID. So you can do $ sweep ID. Now I've got two agents running in parallel that can't talk to localhost for some reason. It's trying to talk to Redis. Redis stopped responding for some reason. What's it using Redis for?
Oh, the GPU manager.
Oh, I see. Or it looks like maybe Redis died. I'll debug if other people have this post lab here. Cool, it worked for him. That means it's just an anomaly, no bug, everything's fine.
Do you have an example of a completed sweep from like last night or something that you can show?
Sure. Oh yeah, that's kind of the best part. So if you are running sweeps, then we give you this sweeps tab. Well, here now we can see kind of like everyone's sweeps, right? So here's a sweep I ran last night, where I have 16 different trials here. And we can see the comparisons here on the right. So we can see that Vocal Sweep 6 was our best performer. So if we go into Vocal Sweep, we can dive in, see what hyperparameters were used. This was the character model, layer size 256, dropout 0.2, and number of layers 3. Seemed to be the best performer in the mnest character group. Kind of a nice way to visualize this across the sweep is using a parallel coordinates plot. So here you can add a visualization and say, OK, I want parallel coordinates. And then we're going to choose some dimensions. So probably batch size, layer size, num layers, dropout amount. And let's say test metric. So this is a pretty basic sweep. So we're not seeing a ton of variance here. But if I just select, say, my top 2 performing runs, what this chart is telling me is that let me get rid of loss. Too much. All right, lower dropout seems to correlate with higher accuracy. And it's a toss-up currently between the other hyperparameter values. I mean, we really don't have enough data here. I would say like one thing with sweeps, especially, you don't start with the sweep, right? You're going to use these hand-rolled tools, use that experiment sample JSON to use your intuition to try some things to get a general sense for what's working. And then when you're in the final process of really refining your model, you might use a dedicated sweep strategy like Weights and Biases provides. So that's the whirlwind tour. Oh, I will say one cool thing you could do with sweeps is our Python API actually has a sweep object. So you can take that same sweep ID and then from the Python API grab the sweep, and then there's a best run method. So you can easily get the best run from a sweep. Anyway, it's in the docs.
You guys have any questions?
So we saw the example of choosing particular GPU by the index or letting it select on its own one of them. What instrumentation we have to do to use both of them?
So really what's happening behind the scenes is it's setting this environment variable that is CUDA visible devices. And if you set that equal to 0, that means it's going to use GPU index 0. If you set it to 1, it's going to use GPU index 1. If you set it to 0, 1, it'll use both.
Oh, I see. That's okay. Thank you.
What's your pricing scheme, or how you manage to make a consumer base, or in the real world, how you charge?
So the question was, what's our pricing scheme? How do we make this work in the real world? We just had venture capitalists give us a bunch of money. We don't need to worry. Now, we're free for individuals and academics and researchers. We really want to be a tool that becomes kind of a standard and is used by as broad an audience as possible. And then we monetize with companies. So kind of the second you're kind of using the tool within an organization at a team level where there's more than a few folks, then we enter into the money conversation. And we charge just a per seat license for the software, so it's very similar to other tools on the market.
What is on your roadmap?
Oh, that's a great question. I've got it teed up. So these are some of the things we're thinking about. So this quarter, we're really doubling down on collaboration. And one feature I didn't show you are reports. So kind of take this sweep. If you thought this was really interesting, you can actually export this view as a report. And then it becomes kind of a document that you can share with the team. It's saved as a thing that will always be there, that will help people understand kind of your journey through this experimentation. And you can export it as LaTeX and actually create really nice academic reports, all driven by the data that's housed in the Weights and Biases backend. So we're doing a bunch of work on that this quarter. And then there's some really cool work around the evaluation piece. So I'm sure Sergey's going to talk about this in future labs. But kind of a new feature we're working on is the ability that once you have a trained model, run inference across the big test set, and then we render really nice UIs to let you say, like, okay, show me the examples that performed the worst, or which ones were wrong, but the most confident that they were right, or ways to kind of surface problems with the model. And then big ticket future items, so continuous integration is a big area of interest for us. So what it looks like for machine learning and ensuring we can provide the APIs and integrations to make that great. And then production monitoring, I think, is an underserved area, as Sergey mentioned. And then it's just general kind of polish and further refinement of the product.
Cool. Well, next up is a 30-minute break. So thanks, Chris.
Yeah, and if anyone has questions, I'm around.